In this video, we're going to define what polynomials are and how to recognize them and identify a few basic characteristics of all polynomial functions, or at least their rules, okay? So let's start by defining what a polynomial function is. We say a polynomial function is any function of this form right here, and we're going to discuss its parts here in a minute, but we notice that we say that this is a polynomial function. Now, when you hear poly, I want you to think many. And so we've seen things that are, classified as binomials before. We say a binomial is anything, we could just make one up here. Like x plus 7 is a binomial because it has two terms in a sum together. We've heard of trinomials, as a matter of fact. A trinomial is anything, of course, that has three terms in it. We can say like x squared plus x plus 7. And then we've even heard of monomials, okay? So mono meaning 1. So a monomial expression would be like 2a. That would be a monomial, okay? But when we say polynomial, we're saying these are functions that have many terms to them, okay? So it could have 1, 2, 3, 4. It could have a 20nomial, But polynomials are just functions that have lots of different terms to them. So when we look at these terms here, we say there are some y equals now. You'll notice that we have a bunch of x's on the right side. Now, the thing I want to point out here about these very quickly are we have x to the n on our first term here, and we have some a sub n. We call this a subscript n because it's just a little n. But we say a sub n is the coefficient of this x to the nth power, but when we say plus, you get over here it says a sub n minus 1, which means 1 less than this n. And we also have x to the power of n minus 1. So basically, as we go from left to right, you'll notice here that the powers are going in descending order, okay? So we say descending order, and we refer to this as the standard form of something that is a polynomial when you have its exponents going in decreasing order. So here's the deal. When we look at polynomials, there are a couple of values we want to pay attention to. And this first one is this. We say this a sub n, or the coefficient of the term that's in charge here, the dominant term. We refer to this as the leading coefficient. So this is going to be our leading coefficient, and we only call it the leading coefficient is because it's the coefficient in front when we put all this in order, and we said it's in order if these are in decreasing order, the exponents are in decreasing order. So we say that the highest exponent is going to be called the degree of the polynomial, okay? So I'm just going to point this out to you here. I wrote some polynomial functions where I've identified the degree, but it says as a side note, we've already familiarized ourselves with polynomial functions. This one right here, we say this is y equals 3 x plus 2, and I say, well, this would be in standard form because I have, two terms. It's a binomial, and we say that the exponents are going in decreasing order here. Okay, so now we say that this is a polynomial of degree 1 because its highest power is a 1. Whereas if I had y equals x squared plus 3x plus 2, this is in standard because my exponents go x squared, x to the first, and then x to the 0, or nothing there. And then also this, we say it's second degree because the highest power on an x is 2. And then last but not least, we say y equals 4, h of x equals 4. You can see that this has no x, so we technically could call this x to the 0 because anything to the 0 power is technically 1, and we would get the same thing as what we had right there anyways. But we could say it's 0th degree, okay, and the leading coefficient here is 4, right, whereas the leading coefficient here was 1, and the leading coefficient on the top one was 3. So now, all of these being said, there are a couple of different stipulations I want to put on polynomial functions, and these two things have to be true also. But you have to have this non-negative integer exponents. And this stipulation is basically putting forth that your exponents can't be negative and they can't have decimals, okay? And then the other thing is this, all coefficients, we mean those a values up top here, all coefficients are real and not imaginary. So like up here we say a sub n minus 1, a sub 1, a sub 0. Those are all real numbers, okay? So now we know that the standard form of a polynomial function, which has non-negative integer exponents and all coefficients that are real, is this form where we put the exponents going in decreasing order. We also have learned that the degree is the highest exponent on the polynomial function. The leading coefficient is this coefficient up front. That being said, what I want to do is I want to kind of classify these going forward, okay? And we were able to identify the degree and leading coefficient of these three. We give things of these degrees right here that you see here, we see them so often that we give them names, okay? So when we talk about a function of the form y equals a sub 0, in other words, like if we had like y equals 4, we would refer to this as a constant function and that it has a degree of 0 because the highest exponent is technically x to the 0. So we get y equals 4. This would be considered a constant function, and it's the graph of a line. We call it a constant function because imagine this. The graph of y equals 4 is just always at a height of 4. Y equals 4. Whereas we say now a linear function, this is a first degree thing. So whenever the highest exponent is 1, like a a sub 1 x1 plus a sub 0. This would be like y equals 2x plus 1. These get their name because when you graph them, they make a line. This is a linear function, whereas we've studied second degree things where the highest exponent is a 2. And we say that this is a quadratic thing. These are those parabola-shaped graphs that we've studied before. And then we're going to get into some other ones that we haven't spent a lot of time looking at. So we say cubic. The highest exponent is 3. We'll call this a cubic. If the highest exponent is a 4, then we'll call this a quartic. Okay. So really quickly, up here, here's what I want to know. Can I identify the ones that are polynomials? All right. And it says decide whether the function is a polynomial function. If it is, write the function in standard form and then state its degree, its type, or its name, and then the leading coefficient. So I look at this first one here, and I notice that, first things first, this 4 is out of order. I'd rather have this written as y equals, we could use y, negative 3x to the fourth, and then we'd say plus 1/2 x squared, okay, minus 7. This would be standard form. And we say, well, what's the degree? So the degree of this thing would be the highest exponent on an x, and we say that this is a 4th degree thing. So it's a 4th degree thing, which would make this a quartic type of polynomial. So last but not least, we say the LC, the leading coefficient. What does the leading coefficient equal? In this case, it's negative 3. So now next, we say this is y equals x cubed plus 3 to the x. Now I notice this 3 to the x, I don't quite know where this goes, and because x could be any number here, what I'm going to tell you is that this is not a polynomial. And the reason why it's not a polynomial is because if x can be any number, then it could be like 1.2, which kind of violates this rule that all of our exponents needed to be whole numbers, okay? So same thing down here. If you tried to put this one in standard form, it looks like we have a negative exponent here. So because of the negative exponent, we'd say not a polynomial, not a polynomial. And then this last one over here, is it a polynomial? Well, I noticed that all of the coefficients, I know pi is a real number, square root of 2 is a real number, negative, a half is a real number. These are all real numbers. And then my exponents, the only thing we need to do is rewrite this so that it's in standard form. So y equals, we'd say pi x squared goes in front because that's the x squared term. We say minus 1/2 x minus the square root of 2 is our constant. And so we'd say the degree. What's the degree of this polynomial? So the degree would be second. It's a second degree thing. It's quadratic type then. So quadratic. Also this, we would say that its leading coefficient. The leading coefficient is equal to negative 1/2. Okay. So this is what polynomial functions are. Those are leading coefficients and their degrees, and that is how you put them in standard form. Cheers.